Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 11, the special role of zero in factoring. Zero is a really powerful number, and classwork opening exercise says to find all solutions to the equation x squared plus 5x plus 6 times x squared minus 3x minus 4 equals 0. Before I get started, though, let's just go to some really basics. If I have 3 times 0, that is obviously 0. If I have 0 times negative 5, then that is definitely going to be 0. And if I have 0 times 0, then that is also 0. So the zero product property basically says that if you have a 0 and you multiply by it, no matter what you're multiplying by is going to be 0, even if it is irrational. 0 times the square root of 5 is 0. So basically what it means is, if you have A times B and it equals 0, so let me just say this. If A times B equals 0, then A equals 0, B equals 0, or A and B equal 0. Okay? So here is an A and here is a B, and because we're multiplying. So either A is 0 or B is 0, or they both are. So to find all solutions to this equation, we just simply say, okay, well, let's make A equal to 0. So that would be x squared plus 5x plus 6 equals 0. And we're going to factor it. Okay. And factors of C, remember, ax squared plus bx plus c equals 0. If you take factors of C that add up to b, that's how you do this. So factors of 6 are 1 and 6 and 2 and 3. Since this is positive, they're both the same sign, and this sign tells us what they are. So the middle term is positive. These both have to be positive. And a positive times a positive is positive. So what positive factors of 6 add up to 5? Well, it's not 6 and 1. Those add up to 7. It has to be 2 times 3. So 2 times 3 is 6. 2 plus 3 is 5. And therefore, this is the factored form of this. So what we have again is another A times B equals 0. So either x plus 2 equals 0 or x plus 3 equals 0. Okay, it's back to this again. It's kind of an AB inside of an AB, if you will. So when I solve this, I subtract 2 over the other side, I get x equals negative 2. So there's one solution. Or subtract 3 over the other side, I get x equals negative 3. So there are 2 of my solutions right here. Okay, x equals negative 2 or x equals negative 3. So if A is either negative 2 or negative 3, or I'm sorry, if x is either negative 2 or negative 3, then A will be 0, and 0 times whatever B is will give us 0. Okay, but we also can look at the B portion and do the same thing. So now we have x squared minus 3x minus 4, and we're going to set it equal to 0. And we're going to factor. This is negative, which means one of the signs is positive. I'm sorry, this is negative, which means one sign's positive and one's negative. And this being negative means the larger sign is negative. So factors of 4 are 1 and 4 and 2 and 2. Well, 2 plus 2 is 4 and 2 minus 2 is 0. So it's not the 2's. So it must be the 4 and the 1. So if I make the bigger one negative, I'll get a negative middle term. So it's going to go like this. Negative 4 times 1 is negative 4. Negative 4 minus 1, or plus 1, negative 4 plus 1 is negative 3. So now I have another A times B equals 0 scenario. So I'm going to say, well, then x plus 1 equals 0, or x minus 4 equals 0. Subtracting 1 over to the other side, we get x equals negative 1, Or if we add 4 over to the other side, we get x equals 4. So if I put 4 in here, 4 squared is 16, minus 4 times 3, which is 12. 16 minus 12 is 4. 4 minus 4 is 0. Boom, b is 0. And it will work for the other one as well. You can always check them and probably should. All right, so there are all of the solutions. So we could say x, might help if I switch back to my pen. We could say x equals, and put them in alphabetical order, yeah. Put them in order from least to greatest. -3, -2, -1, 4. Okay? And that is opening exercise. All right, moving on. Exercise 1. Find the solutions of this. Okay, well, it's the same thing now. And we have x squared minus 9. So either x squared minus 9 equals 0 or x squared minus 16 equals 0. Okay, so in this one, we have a difference of squares. So we have x, whoops, wrong color. We have x plus 3 times x minus 3 equals 0. Okay, these are difference of squares. We did this a couple of lessons ago. I think 9 or 8 or 9 or 10, I don't know, but I don't memorize the names of the lessons or the numbers. But we did do the difference of squares. If we have x squared minus a squared, we get x plus a times x minus a. All right, so now we have an a and a b equal to 0. So either a is 0 or b is. So we say x plus 3 equals 0 or x minus 3 equals 0. And subtracting 3, we get x equals -3 or x equals 3 when we when we add 3 over to the other side. So here are two of our solutions. There, okay. Now they move over to the blue one. That's another difference of squares. Square root of the first term plus or minus the square root of the second term. It is that easy. Forgot my x. Okay, square root of the first term plus minus square root of the second term equals 0. So therefore x plus 4 equals 0 or x minus 4 equals 0. Subtract 4 to the other side, x equals -4 or x equals a +4 when we add 4 on this one. All righty. What am I doing? Okay, so there's the other two answers. So we could say the answers are -3. Let's put them in order from least to greatest. -4 is the smallest. So -4, comma, -3, comma, 3, comma, and 4. Okay. Example 1. Suppose we know that the polynomial equation 4x cubed minus 12x squared plus 3x plus 5 equals 0 has 3 real solutions, and that one of the factors of that is x minus 1. How can we find all 3 solutions to the given equation? Okay. Okay, so if we know this is a factor, then we can divide and find the other factor. So we're going to take x minus 1, and we're going to divide 4x cubed minus 12x squared plus 3x plus 5. So now we're going to use a lesson that we did in this module earlier, and we're just going to do long division. So 4 divided by 1 is 4. X cubed divided by x is x squared. And then we multiply. 4x squared times x is 4x cubed. 4x squared times a -1 is a -4x squared. And then I'm going to subtract. 4x cubed minus 4x cubed is 0. -12x squared minus a negative is plus. This will give us -8x squared. Bring down the plus 3x. -8 divided by 1 is -8. x squared divided by x is x. So we get 8x, negative 8x times x is negative 8x squared. Negative 8x times a negative 1 is plus 8x. And we're going to subtract. Negative 8x plus 8x cancels, the squareds cancel. 3x plus or minus 8x is negative 5x. Bring down the plus 5. Negative 5x divided by x is negative 5. That will give me negative 5x and plus 5. And when I subtract these, I get a remainder of 0. Okay, so I know x minus 1 is a factor, so I'm going to put that there. And then we're going to find the other two factors. So now I want to factor this. So off to the side here, I'm going to take 4x squared minus 8x minus 5 equals 0. So the first thing we always want to do is see if we can factor out a common factor. 4 and 8 would be a factor of 4 or 2, but 5 is prime, so I can't factor anything out. So what I do at this point is, this is the way I do it. I take the first term, the a, and I bring it over here and multiply it by c. This will give me x squared minus 8x minus 20 equals 0. Now I'm going to factor this like a regular polynomial with a leading coefficient of 1. I know I'm going to get x here, and I know I'm going to get x here, and I'm looking for factors of 20 that add up to 8. So if I put 20 here and look for factors of 20, it's 1 times 20, 2 times 10, and 4 times 5. Well, this is going to give me an 8. So I'm going to have minus 10 and plus 2. I needed different signs to get a negative c, and I needed b to be negative, so the bigger number had to be the negative. Got it? Negative 10 plus 2 is negative 8. Negative 10 times 2 is negative 20. Okay, but be careful, you were not done. We multiplied by 4. We now need to divide by 4. Okay, this is going to give us, this is going to reduce. They're both even, so that will reduce to 5 halves. And this will be x plus 1/2 equals 0. And then we take the denominator and move it over here, and we get 2x minus 5 and 2x plus 1 equals 0. So if I FOIL this, I will get 4x squared minus 8x minus 5. So I have 2x minus 5, and I have 2x plus 1 equals 0. So we already knew x minus 1 was a factor. So now we set all of our factors equal to 0. So I'm going to say x minus 1 equals 0. Therefore, x equals 1. 2x minus 5 equals 0. Add 5 over to the other side. We get this, and divide by 2, and we get 5 halves. Okay, and then 2x plus 1 equals 0. 2x equals a negative 1. X equals negative 1/2. So I should have ors here because x can't be two different things at the same time. Put them in order. So my answer is negative 1/2, comma, 1, comma, 5 halves. Okay, there they are in order from least to greatest. And those are the 3 solutions to this problem. Okay, hopefully you understood that. Hopefully you followed this process. I might have done it in my Algebra 1 videos, but there it is. All right, page 2. Is this page 2? It is page 2. Exercise 2 through 5. It says find the zeros of the following polynomial function with their multiplicities. Well, there's a new term right there. And what that simply means is how many times does something have that same factor? So f of x equals x plus 1 times x minus 1 times x squared plus 1. If I set this x plus 1 equals 0, then x equals negative 1. There's 1, 0. If I said x, let me change colors for this other factor. If I said x minus 1 equals 0, then I would say x equals 1. And then finally, I have x squared plus 1 equals 0. Okay. Then we're going to subtract 1 from both sides. We're going to get x squared equals -1. The square root of both sides, that would give me an imaginary number. Okay, so if I took the square root of both sides here, then I'm going to get x equals plus or minus I, which is the square root of -1. We'll get into that later this year. So I'm not going to talk about this right now, but we do have two factors, x equals -1 and x equals 1. Well, the multiplicities just means how many times did that factor appear. So x equals -1 is there once, so that has a multiplicity of 1. I'm not going to write it, I'm just going to say it. So -1 with a multiplicity of 1, and x equals 1 only happened once, so that had a multiplicity of 1. Okay, let's just get rid of this now. All right, let's move on to part B. G of x equals x minus 4 cubed. Well, that means x minus 4 3 times. Okay, and then we have x minus 2 8 times. So this would be x minus 2 times 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 x minus 2. That happened 8 times. So in this case, x equals 4. X minus 4 equals 0, then x has to be 4. And over here, x minus 2 equals 0, therefore x equals 2. Okay, x equals 4 has a multiplicity of 3. And x equals 2 with a multiplicity of 8. So it had that factor appeared 8 times. That's the multiplicity. So I'm not going to write this out again. That was the only time I'm going to do that. 2x minus 3. If I take 2x minus 3 and set it equal to 0, I'm going to get 2x equals 3. Divide by 2 and x equals 3 divided by 2. So my answer is x equals 3 halves with a multiplicity of 5. And I'm not going to write the words. I'm just going to write comma 5. So 3 halves has a multiplicity of 5. Okay, I'm glad I said I'm not going to write these out anymore because we have a 100 here. So 3x plus 4 equals 0. 3x equals -4. X equals -4. What am I writing? X equals -4 thirds, multiplicity of 100. Over here we have x minus 17 equals 0, so therefore x equals 17 with a multiplicity of 4. Number 3, find a polynomial function that has the following zeros and multiplicities. Multiplicities, what degree is your polynomial? So if a 0 is 2, when we work backwards, okay, if we said x equals 2 and we want to subtract 2 from both sides because we want 0 on one side, we get 0 equals x minus 2. Okay, we're just working in reverse. So what it's going to end up being is the opposite sign. So I'll write that over here. We have x minus 2, and the multiplicity is 3, so that's our power. And then for -4, it would be x plus 4. It's just the opposite sign. And that's a multiplicity of 1, so I'm done there. And then 6, that would be x minus 6. Multiplicity of 6, that goes out there. And then finally a -8. If x equals -8, then x plus 8 equals 0. So it's x plus 8. And that has a multiplicity of 10. So it says, find the polynomial function that has the following zeros. What is the degree of your polynomial? All right. So let's just call this, let me move all this over just a moment. Okay, so I just moved this down because I want to name this. I want to put this in function notation and P of X for polynomial. P of X equals this. And it has a multiplicity of 10 plus 6 is 16 plus 1 is 17. Not a multiplicity, I'm sorry. This has a multiplicity of 10, multiplicity of 6, multiplicity of 3, multiplicity of 1. The degree of the polynomial is 10 plus 6 is 16 plus 1 is 17 plus 3 is 20. So the degree of P is 20. Okay, we're not going to find this polynomial because it would be x to the 20th plus some number x to the 19th and all the way down to a constant. And we're not going to do that. Number 4, is there more than one polynomial function that has the same zeros and multiplicities as the one you found in exercise 3? Okay. Is there more than one polynomial function that has the same zeros and multiplicities as the one you found in exercise 3? Okay, so for this, all we have to do is, first of all, we're going to say yes. And looking back up here, since this gave us an imaginary number, it's not going to add to the number of solutions or zeros, real zeros, and the multiplicity will not change either. So I could say P of X, or how about Q of X, call it something else. How about we say Q of X equals, and how about we just use that one, X squared plus 1. So if I put X squared plus 1 times these, X minus 2 cubed times X plus 4 times X minus 6 to the 6th times X plus 8 to the 10th power, then this polynomial has the same number of real zeros, because this is an imaginary number, and the multiplicities, same multiplicity. So if I'm not going to count the multiplicity of this because it's not real, then there is a polynomial. So I can just put any X squared plus anything to get an imaginary solution, and that would be the same degree, same multiplicity. So then it says, can you find a rule that relates the multiplicities of the zeros to the degree of the polynomial function? Okay, so the answer to that is yes. If P is a polynomial function of degree n, then the sum of the multiplicities of all of the zeros is less than or equal to n. Okay, if P can be factored into linear terms, then the sum of the multiplicities of all of the zeros is exactly equal to n. So there's the rule. So since this isn't real, the degree would be 1 less. Okay, but if you can put them into linear terms, x minus 2, x plus 4, x minus 6, x plus 8, this is a quadratic term, not a linear term. So if you can put it all into linear terms like this up here, then the degree equals n. The sum of the multiplicities of all the zeros is equal to the degree. Okay? Okay, page 3 brings us to relevant vocabulary terms. It is a full page. I'm not going to go over this. There's function, polynomial function, degree of a polynomial function, constant function, linear function, quadratic function, cubic function, and zeros or roots of a function. So review those. Definitely need to know all of this. It's very important. All right, page 4 brings us to the end of lesson 11. Review the lesson summary and go to your problem set.